Hello, everyone, and welcome to Handmade Hero. We are going to do some more cleanup work on our current entity storage system. There's really nothing too fancy going on here. It's a pretty straightforward thing we're doing. It just takes a little while because these are sort of larger changes to. They're larger simplifications that delete a fair bit of code, and that's kind of hard to do on stream in a fast manner. It ends up taking a few episodes to do stuff like this. They're not really very hard to do. I mean, maybe they are if you're like a kind of very inexperienced at it. They're not that hard if you've done it a fair number of times before. But either way, they tend to be things that take like a whole day or two to do. So, when you're talking about a stream that only lasts 1 or 2 hours, 2 days could be up to 16 hours of full-time work, right? So you're talking about 8 episodes, 9 episodes, things like that, to do these kinds of larger refactorings. But they're not that tricky. Like, there's nothing all that fancy happening. It's really just sort of removing things and simplifying things because we now know roughly what we demand of certain systems, and they had more sprawl in them because they were handling more cases that we were using before, and now we're saying we're not going to use those cases so we can rip out those parts. And then sometimes that leads to rather dramatic simplifications in some areas, and that's what sort of takes the time, is looking for those sorts of things and kind of realizing what the heck is going on in there. You're like, oh, okay, I see, right? So that sort of thing is really more what we're looking at here. And again, we're just kind of doing that procedure. It's not anything special, but it does take some time. What we're looking at now is just how things like the sim region change. And what we're trying to do is maybe, we may actually be able to eliminate things like this entirely. And really what that boils down to is saying, well, if we just have entities, we will move them into the same space whenever we compare two entities and use their position values together. Then what we really could do is just say, well, we're not going to work on some regions anymore anyway. And we'll just have everything be live in the world structure, and that world structure will just decompress as necessary any entities that it needs to actually access. And the primary thing that we have that will require a little bit of finesse there is just the fact that sometimes entities might want to refer to other entities, and that's not a particularly spatial thing. So the question becomes, do we actually want some way of looking for entities by their identifiers, or do we actually not care about that and everything will just be a spatial query? And if you don't find the entity you were looking for in that spatial query, then you just have a fallback of like, well, I guess I don't know where that thing went anymore, right? And both of those techniques are valid. One is obviously a little simpler, but perhaps a little bit more costly. The other is more complicated, which is tracking the entity IDs explicitly. The reason that's more complicated is now you need an acceleration structure for that, on top of the acceleration structure that you already have. So you have like 2 acceleration structures, one for spatial and one for ID. And the question is just, do you need the ID one? Or can you just not use that? And like I said, don't know. But we can certainly try it. The other thing we can do is if we find that we just don't mind keeping one upper basically ontology that's like, here's the entity IDs just in an array, here's where they all are in space. We could, if we wanted to, we could make that be a thing that we just always keep track of. That's that one piece of information is always stored linearly and can be looked up at any time. And then if you want the actual entity data, it's basically telling you what world chunk that entity's in so you can go decompress it. And I don't know if that makes a lot of sense. Like I said before, it's kind of confusing as to whether we need those things. So I'm inclined to wait until a little bit later before actually doing something like that. Again, just because if we don't need it, I'd just rather not have it in there. It's just another thing that costs code complexity and doesn't actually get us anything if we don't actually need it. But it may be that if we do need it, that's a pretty easy way to do it. And if we find that the number of entities is always low enough that we don't have to worry too much, about that actual array being too large, then we can just use that, right? So there's a lot of options here, and I don't have a lot of strong thoughts on any of them, but I'm just going to go ahead and continue through the process of simplifying down what's actually going on here. So you can see inside the sim region, most of what we're storing here is really not particularly useful. You can see that there's things like the update bounds and things like that, and really we don't need most of that stuff. All we really need is the ability to loop over a series of bounds and update the various entities that are involved, right? Now, I guess I would say we probably can just do that in the update step and not need any of this stuff. And then if you look at things like the brain hash and stuff like that, this is sort of what I'm saying when I'm saying that I don't know if we want to keep doing things this way. What I'm inclined to say is just if we encounter an entity that is supposed to act as, you know, as a controller for something like the head of a worm that's hopping around or whatever, then it just does a spatial search right there for all of the worm segments that it can find that's in its region that belong to it, right? That just gets rid of that whole tracking because you just say, well, you know, entities are always connected. They don't have disparate pieces separated on either side of a giant map that are supposed to act in concert. That's just not something that's in this game. It's not something that's in like any game I've ever seen. But, you know, if you had that in your game, then you wouldn't do this. But in our game, and we cannot foresee any reason why that might happen, so we end up in a situation where it seems like this would be fine. So my guess is we could just take the step of saying, let's just delete this entire thing, right? So all of this whole thing would just get destroyed immediately. It's just gone. And we really wouldn't use anything in it. And we would have the actual use case for these entities where we're going to actually use what would have been unpacked for the sim region. We'll just do that. We'll just produce that information just in time when it's about to actually process it, right? So mostly you just say, okay, we don't really have any of these things. I don't know where like things like this iterate all entities are, where these are actually being, like what that's actually being used for in various places. You can see here that if we look at where it's occurring, it looks like it's, you know, maybe nominally in here. Again, this is a spatial query, which is exactly the sort of thing we're saying we do want to support. So I don't think I care too much about that. We can look in here, and you can see that this is just the main loop, which again is going to be a spatial query, like I wanted. This is also spatial query, right? These are just all spatial queries, right? And so they're just things that we're going to turn into spatial queries. Now, why that happens after everyone moves, I'm not sure. I assume that the reason that happens after everyone moves is just because we want to, like, say, projectiles do their thing after we already know where all the entities have moved. That's an order of operations thing, and I don't know, like, how specific we want to be about that necessarily. Anyway, we look at here for camera movement. Again, spatial query. It's just saying what room are you in. These are all just spatial queries on bounds, right? All of these are spatial queries on bounds, right? So I'm pretty sure that the sim region as a thing is just not necessary. It's just not someone that we actually care about. And so I'm pretty sure we can just vaporize all of this stuff. It's just not necessary and doesn't need to be there. If we go look at what the actual things are that we have in here, such as adding a brain or allocating an entity ID, those would now just be things that are done directly on the world. As you can see, all they were doing before is just thunking to the world anyway. So we should be able to just have people use world specification in general and not have that be a problem going forward, right? Hash occupancy, again, we don't need because we're not going to hash anymore. I don't know if we want to keep these things because they're kind of utility functions for arrays. So we might want to just, throw these somewhere. I don't know exactly where they would best fit in the current set of files we've got. But you could easily imagine like needing them someday. So I'm just going to stick those in here just in case anyone actually wants to call them in the future. They're pretty straightforward, right? They're basically just like bit fields, if I want to store an array of bits, right? Not a huge deal. Anyway, forget hash from ID and all this stuff. This is just deleting code. I'm pretty sure, again, all of it can go. It's all fine. So if we take a look at something like entity overlaps rectangle, again, this is not for, none of these calls actually need to be in here. You can see that they're not actually about the sim region. They don't take the sim region in the first place, and so I'm not sure why they're actually in here other than probably this is where we were using them. So I would just say let's go ahead and move these out into the actual entity code itself because they might still be useful when we're doing collision detection, and so we'll just put them in there because that's totally independent of the sim region. Totally independent, right? Get or add brain we don't need, add entity to hash we don't need, map into sim space we don't need. We don't need any of this stuff. So register entity, not important. Begin world change. Well, so begin world change, we probably do. We're not gonna call this function begin and end world change on a sim region anymore, but I do think that we might want to call it on the world, right? It doesn't seem to really be doing much. But temporarily speaking anyway, I'm going to go ahead and slide that over into the world code because I do want this notion of a solid, I do want to bracket. Oh, I have the function keyword? Good. Okay. I'm going to use that from now on. I prefer that to internal these days. So I didn't actually know that we had that. Can I do a search query replace for internal function? Yeah. Much easier to read. All right. Anyway, so creating and deleting entities, again, is probably, it's something that I'm going to keep in here, and we're going to change it to being on the world because we do actually want that to happen. Checking if something is a room is going to be something that's going to move over to the entity because it's, again, a totally valid thing you might want to do. You might want to ask that question to see whether or not something is a room or not, and so that's going to be a thing as well. The update camera for entity movement, these should probably now move to the world mode. Registering entities, I don't know why I didn't delete that. Obviously, that's not a thing that we care about. And then here are these things about tiles. Those are going to be world queries as well. Again, spatial queries to find out whether things are in a particular tile. So all of these things probably will still exist. And they'll just be on the world. Um, so I think this is all fine. And we just need ways of making sure that these things are relatively fast. But then I think we're fine. So I'm just going to move all these things down here. We'll probably have to make most of those do things that actually matter. And then this will probably go into world mode. Because it's going to be something that we're going to need to call periodically, right? So that just gets rid of the sim region concept. Sim region's now gone, and people will just operate on the world directly, which is just better in general, because if we don't actually need that sim region concept, it simplifies the things that we're doing, which is what we want. And so we can now also just delete those files so that we don't actually need them anymore. So I'm going to go ahead and delete handmade sim region .star, and then remove that from the build. So get rid of simregion.h. And simregion.cpp. And now that concept is just gone, right? It's just not there anymore. Okay. Still have a ton of work to do, but again, just, simplifying things down slowly, like one after the other. And so I think now the next logical thing to do here would just be to make sure that the entity code itself is not using the sim region anywhere. And like anything that it was, so this fill unpacked entity, for example, that was taking the sim region, I think that's the only thing, because otherwise entities were very much not using the sim region, were they? Maybe they were in the update. So you can see in some of these like collision calls and stuff like that. So let's try and simplify this down and just remove sim region from here. I'm just going to look to see where in this code sim regions are actually used. So in this update animation thing, it doesn't use the sim region right now. So that's a pretty easy thing to remove. In applied damage, it does do delete entity. And that would be something that would happen delayed anyway. So I'm pretty sure that this actually does not need to take a sim region at all. Like the way that it's written currently anyway. Maybe we'd want it to take a world later, but, at the moment it wouldn't need to, because delete entity is just a flagging operation, right? That's all it is. And so if we pull this out into our entity code, really all that's happening there with delete entity is literally just we're flagging. There's nothing else that has to actually happen. So, that's a very simple operation that anyone can do, and it's assumed that a sweep will pick up that entity later and remove it, but we don't need any knowledge of who that was going to do that sweep or how, because we're just flagging it as like, we don't need this entity anymore, right? Okay, so going back to entity and looking for sim region, other places where this is used, collision resolve doesn't need it because, again, it's not actually, it doesn't need to actually be placed to be sent to apply damage, which is the only reason that it was taking it in the first place. Update and render entities is using it, which is a pretty substantial function, and that's the only other place. So my assumption is we probably will still need to pass something here, but it won't be sim region, it'll be the world. That'd be my guess. But I want to first look to see what the actual situation is for it to be doing this. So you can see here that it's just iterating over all the entities, so it does seem like that would just be a world operation there. This thing with the move queue got temporarily nerfed out, but it would also be a sim region. Update animation no longer takes a sim region, so that's a false actual use of sim region there anyway. That's just the same iteration that was happening above, so that's again just spatial. Same here, those are the same. And collision resolve no longer takes it. So literally the only thing that we needed the sim region for in any of this is just to loop over the entities that are actively being simulated at any given time. And so to do that, all we really needed to do is just have a, essentially like the bounds that we were previously using to create the sim region All we need to do is make something that iterates over all of the entities that are inside that boundary in the first place. That's all. Right? That's all we need to do. Now, we do have, excuse me, a constraint now, which is that anytime that we move an entity, meaning we set its position to something, we need to actually update that position in the world. So what we're going to have to do here, and I'll do this as a second pass probably. I'm going to go ahead and finish this update pass first. But the next thing that we're going to have to do is basically rename the value of the position in the entity to something else, so that we can, and then we'll go through, and anywhere that anyone changes the position, they're going to need to use a heavyweight call. Because now, changing the position of an entity needs to check to see whether or not it has moved outside of its existing spatial partition node, and if it has, it needs to move to the new node. So that's going to be not that heavyweight, because most of the time you didn't. Like, most of the time it will just be an if that fails. It'll be like, did you move to a new one? No, you didn't, right? But assuming that you do, then it becomes heavyweight. So there is a fairly substantial thing that might happen. Let's put it that way. All right, so all that's fine. No big deal. Let's take a look at fill unpacked entity, which is currently living where exactly? Oh, it's in here. It doesn't take the sim region anyway. So no one cared about that. That's not a thing. Advanced entity stats is doing what exactly? Oh, it's just changing them from their base stats. The accumulated stats become the base. Okay. Ugh, I'm so tired today. The cats were very disruptive last night. Let's put it that way. I did not get much sleep, primarily due to the puss. I need some, like, caffeinated coffee. I didn't have any caffeinated coffee. I had decaffeinated coffee this morning, and that was insufficient. I could also have some sugar. Those two things are basically equivalent. If you take them both together, now you're really talking. Sugar and caffeine together, and that's just like... Phew. Yawning aside. So all of this seems fine now. The sim region is now not mentioned in this file, and it's not mentioned in this file either, other than to iterate over the region, the regional, what's the word I'm looking for? The bounds that we're trying to simulate. And so what I probably want to do here is do that iteration. I'm going to go ahead and say we probably should have... So, one thing that I never really was quite clear on, and to be honest, I really just don't know, like, what the standard way is of dealing with something like this anyway. I'm sure people have to hack something into their code, right? But what I have noticed is that we want to be able to simulate a region where entities are active. And we don't want to have to simulate the whole world, because we want to be able to generate worlds that are maybe much larger than we can simulate in real time. And you only simulate the area that the player is actually in. But what I've never been quite clear on is what happens in the boundaries of those areas. So, for example, if I have an entity and that entity is doing stuff, as he gets towards the boundary of the simulation region, he would be interacting potentially with entities that are outside the simulation region and not active. And so the question is, like, is there going to be a thing where, like, we care about that discontinuity. Like, will it cause us problems? And I don't know. I don't know. And we sort of had a fake kind of solution to this problem. It's not really a solution to this problem. But basically, like, we were marking entities as active versus inactive depending on whether they were on the apron or not. I don't know. I'm not going to think about that now, but just suffice to say that this is a part of the code that we never really had a good policy for, and I still don't know what the correct policy would be. It's not that hard to implement any particular policy you could come up with. It's just unclear what is a good policy because you don't want to simulate everything in the entire world, right? I don't know. So I'm not sure what the right way to do that is, but what I'm going to say now is just like, all right, so suppose we just said that there's a rectangle 2, or I guess it can be rectangle 3, I don't care. That's like the sim bounds. And this is like what we're going to actually iterate over. And then there's the world. And so we would say, all right, iterate over all the entities in this particular world with this particular boundary, and then we just assume that it's going to iterate over all those entities, right? And then everyone else is going to do basically that same thing. So in the other, I'm getting text messages that are interrupting me. Please hold while I turn off my phone. I thought I already turned it off, but apparently that is not true. So if we go ahead and assume that that's all that we need to do, then that pretty much just finishes up this function, right? So the entity iterator is going to be some other thing. It's going to actually, so this is kind of actually what it is. This iterate chunks thing is basically what we would be using and sort of piggybacking on top of. But we would assume that there's going to be an entity iterator to make this simpler, potentially, so that you can iterate over all the entities, right? And so as we go, I forget I can actually use function here. Lovely. As we iterate over all the entities here, something will occur. We'll be storing probably a world chunk iterator and where we are in the entities or some nonsense like this. But then we'll have something here that's the entity iterator that will iterate over all the entities in each block, right? That will automatically expand the block for you and go. I mean, I could do it the other way around, but I'd rather not have that code be duplicated everywhere, so I think I'm going to make an iterator that sits on top of the world chunk iterator for that point. Probably. Maybe. So anyway, there would be an entity iterator, and you would iterate all entities. But it probably would be called iterate entities in bounds or something like that, right? And that you'd pass a rectangle 3 for the bounds, and you'd pass the world, and off you would go, right? Now I think we probably can't quite do it that way because, excuse me, we're going to run out of precision if we actually specify rectangles as rectangle 3s, right? So what we kind of more need to do here is specify this in some way that, the sim region concept, we're getting rid of all of that storage and all that stuff, but we maybe still want to retain just this kind of notion that there is a center point and a radius, because we need the world position to be we need to be able to iterate over entities relative to a world position, which is much more specific than a floating point number, right? So that needs some special consideration here, and I'm not sure exactly what we want to have as our basis for that. We've got world position. And then I assume we want just a radius. So it's probably like sim center and then just radius. Something like that. Sim center, sim radius. And then you pass those down. Something like that. And so again, like, I don't know to what extent we want to keep the concept of a sim region. You could imagine something like this. It's not a sim region per se, but now it's like a world region, and you could imagine just putting those two things in here. That might make some sense. So now the sim region is just literally a region instead of something that has storage. I think I might like that better because it just means you don't have to pass as much stuff around. And it's less like clear like what's going to happen, that these are common sort of things that occur. So maybe we call it that. And then whenever people are iterating entities, they're iterating like entities in, let's say. Iterate entities in. And then we just do that for the rest of these things where that was happening. All right. So I think that's roughly what I want. It seems fine. World Sim and World Sim work. This doesn't really look like anything that we need anymore. Because what would the temporary memory even be for anymore, right? So I'm going to go ahead and say that World Sim is probably not a thing we need. Yeah, I mean, that's just kind of... It's just kind of unnecessary. Like, all this is basically... All of that stuff was just for doing multi-threaded world updates. Right? And so to the extent that that's actually going to be a thing that anyone cares about, those are World Sim work, which is this stuff here, right? But actual World Sim... How come I can't step through the actual results of this thing? Lame. So I would say that I don't think we need this. I really don't think World Sim and then this Begin Sim stuff, I don't think we need any of this stuff. So I'm pretty sure that can go as well. I'm just going to delete it, and we'll deal with the consequences downstream. Okay. Keep going. The world generator needs a pointer to the world, but it will no longer need a pointer to a sim region, so we'll just get rid of that. Add entity now is really just a thing that happens on the world itself. So this whole thing is really just a world operation. Why this is happening on the region? So we have add entity and create entity for some reason, which all right. Let's just throw that up here for a second. Create entity. So if we look at these two functions, add entity and create entity, I'm not sure why there are two of those. Probably just like historical accident that this is like the process that things went through or something, because they're really just the exact same function, and the only difference is that like they're basically two calls. They're both create entity, right? It's just one allocates an ID and one takes an ID if you like already had the ID reserved, right? They're exactly the same. Now we will presumably want to, if possible, like we want anyone who happens to know where an entity is going to be when they create it to be able to pass that so that we don't do two insertions into our spatial data structure. So that's a thing like we're going to want, right? So sorry, I just looked at chat for a second there. So I think that's probably all fine. What I would say is like, yeah, we just name them both create entities so that we don't have this weird thing where there's an add versus a create, which doesn't really make any sense. They probably, like I said, should be taking a position, so like a world position, where this thing is going to be, and that's again because we want it to be spatially sorted. So that's fine. The world stuff here, this whole thing is going to be a thing. These entity access stuff probably should have been happening, I would think, in every case, so I don't know why we only had it in one of those. But okay. And then I think we're pretty much done here. This is the thing where we'll actually... So this will have to become a new call. These will probably want to move down a little bit. Oh, this is an entity. Sorry. These will go in world. And this will have to call something that actually provides space in a world chunk. So that's, simple code, but we haven't written it yet. But that's where the entities will actually come from. Now, they will no longer be in a region. They will, they will be in some world chunk that we get by accessing that world chunk using its world position and all that nonsense, right? So that's fine. So now there is no add entity. That's not a thing that happens anymore. Then so now we're basically on to the world code itself, which is good. That's where most of our rewriting has to happen now. I'm not sure how our other functions look, but I mean our other files look. But there's no reason we can't just start writing the world stuff because we have to write it either way. So if that's the current thing where the first error is, then that's just what we'll start on. So what we want to do here is set up our world storage, like I said. So there's basically two versions of it. I'm not sure I understand this. Correct me if I'm wrong, but that should be union, right? So basically what we have is this concept of entity block storage, which is a particular thing that's like large enough to hold a packed entity block or an unpacked entity block. And what we would do is the packed entity block version of this just stores stuff at the end, however much there actually is to store for packed entities versus unpacked entities. We can tune this to whatever we want. Right now, there's 16 entities stored per block. We have no idea at all what that number should actually be. Let me look at this to-do real quick. It seems like we have to store chunk XY with each entity because even though the sim region gather doesn't need it at first, and we could get by without it, entity references pull in entities without going through their world chunk, and thus still need to know the chunk XY. So yeah, I mean, essentially what's going on here is you have to remember that now our entities themselves are all coming from a particular world chunk. So you wouldn't need to store in the entity what world chunk it was in because that's where you got it from anyway, right? So you really only need the offset to be stored in the entity. And so we may want to make that adjustment. I just don't see any reason for that adjustment just yet, but it's definitely something that could be eliminated. It's definitely something that can be eliminated in the future. And you could imagine doing something like this. Or I mean, that, which is probably, just making the chunk be a V2S makes a lot of sense, right? So I don't know. But it would make sense to do that where basically the entity would just store its offset, and that's all you would actually need. So producing a world position from the entity would just be as you're iterating over that entity, you know which chunk you pulled it out of, and then you know what the offset is for the entity because that is stored in the actual entity. So that would be interesting, to say the least. Yeah. So I'm down with that. I am down with that. Okay, so yeah, let me think about this some more. I think I got about an hour left here, so I can do a fair bit more of the stuff in this before time. So let's think about this. What is the next thing that I'm going to do? Probably what we want is to solidify the actual like chunk storage here. I'm not sure where null position gets used. Apparently null position does not get used. So maybe we will just not have that for now, and if we do need a null position in the future, we will figure out how to do that later. If we want to check out something to see if it is a valid chunk, does that happen anywhere? Oh, this is going to be a pain to search for. All right. Okay. So anyway, yeah, I don't know about that is valid. That doesn't seem great. But anyway, if we look at what chunk we're in here, we can now just do .x.y. And really that's would have done the subtraction for us anyway if we'd wanted to, which is nicer, right? So that's actually kind of nice. We probably could just do that at some point. I don't know if I care about it right now, but and then these are just like .x, .y, .x, .y, .x, .y, .x, .y. And then .x, .y, .x, .y. I don't know what a tile chunk safe margin is. Does anybody else? What? So it's 1/64th of the total world size? So why would we care about being 1/64th of the total world size? How did we come up? Does anyone remember how we came up with that number? It seems like a very strange number. Like, wouldn't it be more like int 32 max minus 256 or something, or minus 1024? Like why would it be 1/64th of the largest number? I mean, it's fine. We're never going to use that many anyway, but like I guess I just don't know how is that the margin? Like what does that mean? To be fair to us, we did say think about what a real safe margin is, so I guess I won't really belabor the point, but it does seem a bit weird anyway. So we've got this tile chunk safe margin in here. It's only used there, so I'm going to go ahead and move that down to that location, and someone can figure out what the heck that's about at some point, because it's probably not the actual value you would want, but I don't know. Yeah, I believe it was arbitrary too. I mean, unless we really had some way of thinking like, oh, 6 bits and the sign bit should not be used. So like, well, the sign bit is used, so 6 bits are not used. But why 6? Like, why did we want 6 extra bits? What are those bits for? Like, I don't know. I agree we do want a safety margin here. That just seems like a fantastically large one. Like, if you think about what's going to happen when you're simulating regions, you want a safe margin that is roughly the size of a simulation region so that nobody will wrap around the world and pull in stuff from the other side, right? I mean, like we're ever going to get a world that big. But if you did, that's what that protection would be there for. It's basically saying, look, we're not going to allow creation of things near that boundary, so assert if anyone tries to actually make something there, so that we know that the generator is not respecting that boundary properly. But I just don't see how divided by 64 makes any sense. My assumption would be that the more sane thing here would be something like int32 max minus 1024 or something, or minus 4096. Like some number of tiles, it's not really tiles, it's chunks, of a gap, right? And 1,000 seems like way more than enough. 1/64th of the total space, which is what, like 2 billion divided by 64. I don't know what that is. But it's just too big, right? So if I said, oh, it's 2 times 1024 times 1024 times 1024. How do I get this thing to... Is it fixed decimal? There you go. So that's the size of an integer, right? And if I divide that by 64, it's like the headroom is freaking massive, dude. Like, that's how many chunks are like left as a safety margin. I mean, what? Like, that just can't be right. So I don't know. It just seems dumb. So I would say a minus makes more sense here. And we're just going to, that's what it's going to be. I'm not comfortable with putting divided by 64 because I have no freaking idea why we would do that. So. All right. So here we are in get world chunk. Basically, the problem we have here is that if the we need to be able to allocate size here. You can see world block size divided by size of world chunk. Yeah, this doesn't really, none of this is what we want anymore. It's close. It just not what we want anymore. So on here, I don't know why we want to do these. This is presumably like here because we thought maybe to be honest, I really don't know why we did it this way. This doesn't make a lot of sense. I don't know why we would bother with this kind of thing. We were allocating these in bulk for some reason, but I don't know why we would do that. Because we have our own arena for it. So there's no reason to allocate them in bulk. Right? So that's pretty strange that we did that. And maybe we had a reason for it. But I don't know what that reason would be. It's like if you thought that pushing the array took too much time, which... I mean, maybe that could be the case. But, like, I mean, I guess it depends on how much other stuff we're putting into this arena. You know? I mean, I could believe that maybe this was efficient. That maybe we want to do these at a fair number at once. I don't know. And so you're saying, like, look, I want to push on some number of these world chunks at once, just because I do. And so that block size is just there for this purpose, right? And that's just like, oh, we're going to allocate a megabyte of world blocks at once, or whatever. I don't know what that number should be. I mean, 256K, maybe? Something like this. Like, maybe we just say, look, if these come in 4,000 4K pages, we'll just allocate, 64 pages of world chunks at a time or something. Again, this feels a little bit overkill-ish to me. But, I mean, it's fine. So then if we take a look at what's happening in the actual provisioning routine here, when we get a world chunk, we now have two things, a packed and an unpacked. These should probably now be a V2S. I might as well make that change as we go. And because why not? The first packed and first unpacked have to get initialized to 0 so that we know that there's nothing in here. The next in hash is going to get strung along to wherever this was in the hash table, obviously. The chunk P can just be set to the chunk P. And we can pass in the chunk P as a chunk P now because we have V2S's. I'm imagining when we originally wrote this code, we didn't. And that's why they're passed as an X and a Y separately. So really that's all. So get world chunk is just going to do that, and it's going to allocate the chunk. I do question slightly whether this is something that makes sense to do. The only reason I say that is because, well, you know what? We pass an arena here, so we can do a get chunk that doesn't allocate. So that's actually fine. Never mind. It's totally fine, right? So this is all good, and you just don't pass the arena if you didn't want to actually allocate the chunk, and that's totally fair. I don't have a problem with that at all. All right. Get world chunk internal. I'm going to change these to taking a chunk P as well because why not? And off you go. Okay. I think we are now on to the actual meat of this thing here. Oops. PX, chunk PY. What time is it, by the way? Does anyone know? 15:30. All right. About 30 more minutes. So let's take a look at the rest of this stuff. So get world chunk, that seems fine. Remove world chunk. It just has to use the chunk P. I don't know if this is a thing anymore. This doesn't seem like something that we're gonna actually want to do. So I'm pretty sure like remove world chunk is just not a thing. We will not be like cleaning up world chunks ever. I probably shouldn't delete it, I guess, but you know what? I'm gonna, because like that just shouldn't happen. You're going to remove entity blocks when entities get deleted. If the entity block becomes empty or something, right? Then you would like release that entity block. But you're definitely not going to want to do like removing world chunks, because those are just mean that's a section of the world that exists, and that's fine, I guess is what I'd say. So anyway, fine by me. Get world chunk, that's all good. Remove world chunk, not a thing. And then we've got create worlds. That's all fine, and that's basically just us deleting a bunch of stuff that we don't care about anymore. So we've got the max unpacked entity count, the unpacked entity threshold, the unpacked entities, and all that stuff is not a thing anymore. We may still want the null entity, so I'm not going to delete that, because I don't know if we may find that we want that sort of thing. We want our first free chunk to be initialized to 0. Certainly. Everything else seems fine. This is gonna clear though, right? So these don't need to do that, right? We only have to initialize things that are actually non-null, because push struct is by default going to clear. It does not pass no clear. So you know. Okay, so no big deal there. No big deal here either. Although I feel like we could just convert these to F32s after doing the subtract. I don't know that there's a point in subtracting in float. Like, unlike multiplication, subtraction in integer is fast. So I don't know that you would intentionally convert to floating point before subtracting for any particular reason. So it kind of seems like we can just do like yeah. It kind of seems like we could just do a chunk p minus b chunk p like that. And then the z delta is 0, right? And then we just need to convert this to float once after the subtraction is done. It's just a little cleaner that way, right? Let's try that. So that's just a little bit cleaner. It's just less fussing, right? So that's fine. The chunk dim in meters now no longer has a z value, so I'm not really sure that we should be doing it this way, because we are producing a v3 result using this multiply that's multiplying out a value we don't actually need, right? So that's a little strange. I mean, it's fine, but it doesn't make a whole lot of sense. So anyway, has room for this. Now we're getting into the stuff about packing and unpacking entities, so that kind of has to be handled with a little bit more care, like this use chunk space and all that garbage, right? And we've got these like ticket mutex in here. So if multiple people were doing simulation at once, the problem that you're going to have is if they overlapped I think you would be in trouble anyway. Like, so the problem that you're going to have here is that a ticketing scheme on the entire world is just dumb. Like many of the things that were done in Handmade Hero that have to do with multi-threading, they're pretty much all stupid, and this is one of them. Specifically, two people who are both operating on the world do not want to take ticket mutexes against each other if they're not operating on the world in the same place. Now, fortunately for us, we don't care about multi-threaded world update anyway, so we could probably just remove this stuff and say we're just not doing that. And I think that's probably what I would do here anyway, because if we actually cared, like if we actually wanted to do multi-threaded world updating, what we would actually do is we'd put a ticket mutex like per cache line, and we'd store the free blocks per cache line, so that way the only thing that you lock is the cache line you're actually on, or even maybe just the block that you're on, and you have a per thread store of blocks that you cycle in or out, right? To avoid ever having any conflicts at all. So that the only thing that you prevent is two people updating the same region, right? So I think that's one of those things that's just kind of dumb. And so I would be inclined to just remove the ticket mutex entirely. And if we want to put multi-threaded updates into this you would not do it that way. So I don't really want to leave it there and pretend like it's a good thing that we want to keep working, because we really don't want this. It wouldn't be good if it actually came time to do that for real. We wouldn't want to do that. So we'll just remove it so that nobody thinks they can multi-thread a world of it. And then if we actually do want to do that, if we decide to support that in the future, we would change around a little bit about how this code works internally to avoid having that occur. And I'm pretty sure we would want to do that and not just keep it going the way that it's going currently. Okay. Excuse me for a second. I've been very stuffy lately. I think it's just like wintertime. The heat is on. And I dry out. I need a humidifier, but then if you get a humidifier, the humidifier gets moldy, and that's a pain in the butt. If someone could invent the mold-free humidifier, that would be, like, so good. There are many humidifiers that claim that they, like, will be mold-free, and they totally aren't. Like, you can go buy any like, thing that advertises mold-free humidifier on Amazon. You can buy it and put it, and it will have mold within like a few weeks, even if you're like washing it out regularly. They are so totally not mold-free, it's not funny. All right, so let's just try to wrap this up here, because we're kind of winding down on time. Looks like we got maybe about 20 minutes left. Maybe 30 minutes left, something like that. Let's just try to finish up some more of this like world chunk code. So, oh, and it looks like we already sketched out this fact that move entity to new position was going to be a thing, right? So we kind of already know that that's got to happen. So we were thinking about it, right? So that's good. Okay, so if we call ensure chunk is unpacked, basically all we're doing there is we're going to... so there's a couple things we have to say here. So in the outset, just for getting the code working, the only thing we really have to care about is unpacked entities. We don't really ever need to pack entities either way. However, we would eventually like to pack entities because entities are probably too large to store all the entities for a large world in their completely unpacked forms, so we probably want to be able to support that eventually. This is very simple. There's not a lot to it, except for one thing, which is knowing which chunks we would actually pack. Now, the reason that that's difficult is, difficult is a very relative term here, but the problem is that if we get up to a very large number of chunks, which maybe we will, we really don't want to loop over all of the chunks to figure out which ones to pack. So we have to have, or we probably will want, I should say, a way of tracking all of the chunks we've unpacked so that we can pack them later. I'm having a thought about that. The thought is as follows. What if we just keep a rectangle that is the rectangle, the world bounds of everything we've unpacked? And then when we call pack, we go through and we pack all the things in that rectangle that are the furthest from, that are like outside of a certain radius of the player or something, and produce the new rectangle that's the things that actually are still unpacked. It's not a terrible idea. You know what I'm saying? I kind of like it. Let me think about this for a second. So the only thing that I can think of that's like not great there is what happens if you discontinuously move the place where you're simulating by a large amount. You would need to like detect that and start creating a new rectangle, or immediately pack all the people who you jumped away from. Just pack them immediately. Or something. Like, I'm just thinking about like what happens if the little dude teleports or whatever, right? Which, because we are not doing Z anymore, will happen. I guess you can just treat it, I mean, honestly, you could just treat it as like a K clusters thing. If two things are too far apart, you just start a new rectangle. That's probably the easiest. And then you just say, like, periodically, you just go through all of your rectangles and you test to see if any of them are like, have been accessed recently or whatever. That seems easiest because then you're not like storing, you don't store any kind of like, you don't store any weird stuff, right? You don't store any things that are like, you don't have to store like linked lists of unpacked stuff, which is something you would otherwise have to store. So I don't know. That one's a little bit weird. I'm not 100% sure about how we would want to do that, but it would probably look something like this. Right? So you'd just like straight up track some number of unpacked regions, like who knows how many. And then periodically you just loop through those rectangles, and that's it. That seems pretty good. Now we do probably want an access sequence number at some point here. So when you unpack something, or like access, when you call ensure chunk is unpacked, you would probably want to pass in a sequence number so you can check the recency, like how recently was something unpacked. Maybe. And so you do want something like that. So yeah, the algorithm like the sketch of the algorithm is very simple. Every time you unpack a chunk, you add that chunk to the rectangle that is the unpacked chunk rectangle that just bounds them all. You can keep multiple of those, so if something is too far away from the existing rectangles that it would create a much too large rectangle, then we just create a new rectangle for it. Every time we process, who cares how many, every n frames or something, we check one of those rectangles, or maybe each frame we check a rectangle. And we look to see if the last time it was accessed is more than, 200 frames ago or something. And if it is, we pack it. Right? I mean, that seems pretty dumb and simple and seems fine, right? I mean, seems fine. I don't see a problem with it. The main problem is I'm just too tired. I need to go back to bed. That's the problem we've had all day, is just being tired. So, okay, ensure chunk is unpacked. It's just unpacking entities. That's all that's going on here. And so what we need to do is we need to be able to cycle free chunks, which we have here, right? I believe those should now technically be entity block storage chunks, is what these actually are. But we're using packed entity block, I guess, as the unit of linkage there, which is fine. So when we when we do this, we need to pull a first free block off the chain. And so we need an allocator for that. Now, where we have here, use chunk space is up here. Yeah. So use chunk space is going to have two parts to it. This part here is going to be now shared, basically. So basically ensuring that there's always like a free block available is going to be the same, regardless of whether you're using an unpacked or a packed entity. And other than that, I just have to check the rest of the stuff. What does clear world entity block do? Is that called in multiple places? It is not. So why is that just not in line with this thing? Like, if this is the only place that can do it, why is that? That doesn't make a whole lot of sense. It must have been, it used to be used somewhere else and now it's not, or something. Um, right. Ooh. Um, so instead of clearing it, calling that function, we would just do it here. And this especially doesn't make sense because the next pointer gets set right here, so we don't really even need that. It's just entity size. So I don't know. I don't know what the point of that is. All right. So anyway, use chunk space needs to have this part pulled out. So this first free block, like we just need ensure free block exists. And that's just something that both of these people will call, and literally all it is just the thing that ensures that if there is no first free block on that free blockchain, it will add one on, right? That way, this can never fail, is really all that's trying to make sure happens. So we need to ensure that there is a free block available, and then we keep going. So use chunk space probably needs to change. It's more like use packed space, right? We're specifically talking about that. So we're saying, look, if there isn't a first packed block, or the first packed block doesn't have room in it for something of this size, right? This also is something we're going to have to deal with here a little bit. So we don't have a way of determining what the maximum size is here other than computing it against the unpacked entity block, right? And we want these things to always be the same size, but that size would change. So I guess... So here's a question for you. Can you just do this? This is really out to lunch here, but... if we just said, look, however big an unpacked entity block is, that's how much entity data we're going to store, minus however big this is. I don't know if we're allowed to do anything like that. Couldn't quite pull it off. I really just want to say, give me something that's this size, right? So, I mean, I could do this. It's just a pain in the ass. Right. right? So I think that would do it. What does that say? Any data size is not a member of yet, right? So it'd be like header dot, right? So I could do that. And then it's computed automatically, and maybe that's better. Once again, like C, C++, uh, this should be like such a fundamentally straightforward and simple thing to do. Like, you should be totally able to just say, I would like this member to be however big it needs to be for this to be this size. Should be a trivial thing that, would be one little tiny syntactic thing. It's just a basic operation. But of course, they make it a pain in the butt. Because, they're too busy adding stupid crap instead of things that are actually useful. So, this seems fine. Maybe we just do this. I don't know. It's really annoying to have to add that in there, but C++ makes it so that it has to because, they don't care about you. So off you go. All right, so that's really all that looks like. It's not very complicated. So we can do it that way. I don't love it, but nobody ever asks me. Nobody ever asks me. So if we and they ignore me if I tell them anything, so it doesn't matter. So it's basically like might as well piss straight into the wind. Something tells me that if I was programming in JAI, this would probably not be a problem. Like, there's probably a way to say I would like a frickin' struct to just have as much, to make the size of this thing be however much it is for it to equal this other thing. I could probably just write a little meta program in the little meta thing that would just do that, right? Because it's like a frickin' one subtract, right? I don't suppose John's on here, is he? He's probably got better things to do at this time than watch this nonsense C code. But because I would be interested to know. Like, that's just a basic thing I want to do all the time. It's extremely simple, but as far as I know, like, there's no way to do it in C++ at all. Yeah, he may be at the firing range today, but I will ask him. I'm curious because that's just a basic operation, I would think. He has probably done it, but I don't know. The meta program would certainly be able to do it, but it may be that there's even a language feature. I don't know. Anyway. I think that's it. I would say, like, another way to do this, maybe we can simplify this down even more, because we could imagine like going this route, sort of. Or not even. You just like cold cast this to a U8. Right? So, I mean, maybe we just don't, because C++ is such a pile of garbage that like you can't make these things type safe anyway because they're just like too cool for that. And so maybe we just call these things entity blocks in general, right? And we change to just talking about any entity blocks generically, and then the count is just like two different things depending on the circumstances, you know, right? Something like this. Anyone? Does anyone care? Anybody? Not all at once now. You know what I'm saying? So you can basically ask if it has room for a certain number of packed bytes. Or you can ask if it has room for unpacked bytes, right? Unpacked entity count. Does that seem... Yeah, nobody cares. I don't think anyone cared. I care. But that's, you know, that's just me. So fine. That's fine. We're the only people who care. What's, you know, that's par for the course. So let's go ahead and say we'll ensure free block exists. We will use that in both cases. Now we don't have to do the header thing anymore because that's actually correct. We have a count here that's going to be initialized to 0 when we have a new block because there's nothing in it yet. Everything else stays exactly the same. Now, when we do pull something off and we want to put something into it, all we're going to do is take the count there. So basically, we're going to U8 star this entity data. And we're going to add to it however much of a byte count we've gone forward. And then we're going to add the size to the count. And it doesn't need to be truncated because it's actually a U32 now since we unified those. We want to check to see if we have room for however many packed bytes we're going to stick in there first. Because in case this function that we just rewrote is actually totally buggy and we didn't do it right, we would like to know that instead of overwriting memory. And that's all I think we need to know. Use chunk space with the world position here is just a convenience call. I don't even know if anyone uses this convenience call anymore. But just in case they do, here you go. Oh, whoops, that's the wrong call. Right parameter change. Wrong call. Is it just called chunk? Yeah. Probably should be called chunk index. All right, so I don't know what the heck add to free list does. I mean, I assume it adds something to the free list because that would be what you would expect. I don't know what first block, last block is, but I guess those are saying that if you're adding an entire chunk to a chain. we wouldn't have this case anymore, ever. We don't free groups. We would only free things when we sweep over. We'd free chunks individually, so we don't actually need this. We just need the basic chaining option. So add to free list would literally just be so first of all, this part just is a complete non-issue. Like, that just never occurs. This does, which is to say that old block is here. The old block next will become the first free block. Will point to the first free block, and the first free block will become a pointer to the old block. So this will just be added to the chain. That's all that needs to happen in there now. So that's all fine. And then yeah, so I think we just need a I don't really know if we need the used packs. Like, when we ensure chunk is packed, we could just do this in line here. So I don't really know why we're doing that. It's kind of weird, right? There's some other things that probably are dumb if you think about them. So if you assume that entities, and maybe this isn't possible, but I think it probably would be given the way that we're doing our entities. If you assume that entities, when packed, are always smaller than unpacked, then the unpack code would just unpack the entity in place, probably, right? Or you could just use a temporary that you copy the packed bytes out into first, right? And that might be smarter than actually cycling the blocks themselves, because it would keep the memory for the blocks closer together in general. So, but since you're storing multiple entities at a time, it probably doesn't really matter. My point anyway, though, is that I don't know that we really need, when we do ensure chunk is packed, I don't know that we need to get like that used chunk space thing. Well, or it's used packed space now. That can just be done in line to that function, because you never actually do anything else. You never use packed space in any other context. You know what I'm saying? The only time this is ever going to happen is when you're packing a chunk. That's it. Using unpacked space actually might be something that you wouldn't have, that wouldn't only be done in there, because people do add individual entities randomly, right? So yeah. I feel like there's a lot of pretty cool stuff you can do in here, and like as we go, I'm kind of interested to see how it plays out. But yeah, so anyway, so in use packed space, which only ever, so who the heck was ever calling this thing? Like, nobody. So I don't even know why this stupid thing is even here, right? So use packed space is actually could just be welded directly into the ensure chunk is packed function. And then it's literally just this code right here is what the only time we're ever going to actually do this op is right here, right? We say if this entity is not deleted, then we go ahead and make sure that we can fit him in the chunk, and if we can't, then we get a new one, right? Otherwise, in any case, afterward, when we know we do have a valid chunk, then we just go ahead and get the destination out of that, like so, and call it done, right? So like this is the entire freaking routine. Like that's it. And what we need to do here is just loop over all of we just need to make the loop actually loop over each chunk that has been unpacked. And presumably we're only ever going to do that when we like in both cases we throw them away, right? Where did that add to free list go? Yeah, here it is. Right, so in either case, we throw them away. So presumably, like, these functions are they're going to swap between the two. Like, you pretty much always have either an unpacked or either a packed, but never both. Because as soon as you pack, you are assuming that you're getting rid of the unpacked storage, because otherwise, why would you be packing it in the first place? And anytime you unpack, well, you're going to modify the data. So the packed data is old anyway, right? If that makes sense. So we just say while chunk first unpacked for entity index equals 0, entity index less than chunk count plus entity index, entity equals chunk entities plus entity index, and then you pack it. And that's it, right? Then you just pull it off of the list. So you say chunk first unpacked wait, this is not chunk. Entity block. This is the block. Sorry. There we go. So you take this first unpacked chunk and you pack it, right? And I'll call this unpacked just to be clear, because there's two. When we're going from one kind to another, I feel like it could get confusing. So I probably want to do like instead of new block, we just do new packed, right? Just so everyone knows what the heck we're talking about here. So basically we have an unpacked and a packed. We're copying between them. When we're done, we just say, well, okay, we're going to release the unpacked back. But first, we have to set the first unpacked equal to the next one in case there's another one that follows. And this just is a loop that loops over, right, all of the entities in all of the unpacked blocks, packing them, and then throws away those blocks, right? I mean, no big deal. What's the problem here? Ensure chunk is unpacked. We haven't looked at quite yet. So that's just, we'll deal with that in a second. So let's first do this one. Has room for packed bytes. What is the problem? Size. Oh, it's packed entity size is what it should be. The world's first free block equals new packed next. And then there was some other complaint down here. Has room for packed bytes, packed entity size. In both cases. And then we're done. And that's the packing routine. The unpacking routine is the same frickin' routine, right? Where essentially we also, so the thing we want to do is when we do an ensure unpack, like at the end of these, we just want to assert, right, probably that the thing, either it has one or the other, but not both. So I probably want something like, maybe this. And I'll just write a function called chunk is valid that kind of just does the basic work of making sure that there's not weird things like chunks that have both of these pointers. So this is just like the result is chunk packed. It can have neither, right? So it'd have not and not. Or it can have one and not the other. Or it can have the inverse of that. And those are all valid conditions. The only thing that's not valid is if it had both. In fact, I guess that's the easier way to do it. Just say result equals not chunk packed and chunk unpacked, right? Because all the other cases, you can have none, you can have one, you can have the other, you just can't have both, right? So as long as we don't have both, we're all right. No worries. If we have both, bad. Like somebody do something. Okay. So it looks like we want to keep this loop here. And we want to do first packed now. Packed entity size we are still using, even though technically in the future we probably won't, because packed entities will vary in size. But right now we're still doing the basic op. So we are basically saying first packed entity, and we do need the free list cycling here. So we would do first packed equals packed next, and then we'd add the packed to the free list like so. So in here we would just say, okay, for each of these bytes in here, advance however far we need to. And like I said, in this one, it's going to be a little bit squinkier because or rather, it's going to use an external function because we do want to be able to use entity space in unpacked chunks. And we don't really need to do that externally for packed. So this one is all one self-contained, straightforward thing. This one will call out to get this dest pointer because other people are going to want to. Like when we add entities, we're just going to want to append, right? So I think this all works fine. So this is all fine, and this needs to be the equivalent of this for unpacked. And we're going to want to do it in a function because, like I said, other people, like the add entity call, will do this same operation. In fact, it really just is the add entity call. The only difference is it doesn't need to do the initialization of the entity because we're going to romp it, right? So effectively, we would just have create like entity internal, something like that. You know what I'm saying? And create entity internal would take the world chunk. So you just say, I'm creating an entity in this chunk. And then both series of calls will call into that. Both this path, which is just packing a chunk, and the other path, which is adding an entity to the world just somewhere, right? They would both call this. So there is it's not as simple as that, actually. So I think I probably have to do it a little bit more explicitly. I know this is probably difficult to understand because nobody is thinking it through. They're just watching the stream. But the problem that we will run into is that in order to create an entity in a chunk, that chunk would need to be an unpacked chunk, because otherwise you would be adding an entity just like willy-nilly, right, to some chunk that might still be packed. We happen to have a chunk now that we want to add an entity to that's in the middle of being unpacked, right? And so given that situation, we need to distinguish between the case where you would need to call ensure unpacked or not. Now, it's probably fine. What we can do is just make sure that the thing above this actually does it. Stay thirsty 90. I appreciate that if you're actually thinking it through. So anyway, this will not quite. It will literally just append to the unpacked state. It will not call unpacked first, and the other create entity call will. It's a little subtlety there, right? But anyway, so it would basically just be this, and we assume that returns our dest. Everything else here just works fine. And then we just need create entity internal. And I think we're good. Frist. Okay. So, this is just U8. And, this is from the packed block. No, yes, this is from the packed block. And I think that's all fine. All right. Okay. So create entity internal is the only thing we actually now need for this all to work. And create entity will need this as well. So the actual later call to create entity would call the same function. It would just call the ensure chunk is unpacked part first, if that makes sense. So assuming that we come in here, we have created an internal, and we've got the world chunk that we're talking about. Our code will look basically the same as this. So it's just going to be like this exact thing. It's just going to be operating in terms of entities instead. Now, at that point, it makes me wonder why I don't just call the same function, because all you would do is call the same function, but you'd pass the size of an entity. So that makes me feel kind of stupid for being stupid, which is a good reason to feel stupid, actually. Because, yeah, like, why don't I just call that in both cases just with a different size? I noticed nobody mentioned that on the chat. What is your excuse? If you actually were thinking this through, yes, you in chat, why didn't you notice that already? Hmm? You claim to be thinking it through, but if you were, how come nobody... You're telling me literally everyone in the chat got there after I didn't see it? Everyone in the chat, all of these people thinking it through? I'm suspicious of that. I'm very suspicious. I think some of you were doing things like checking your phones or eating Cheetos like I was doing earlier in the stream. Very embarrassing. All right. So yeah, like it seems like I'm kind of just dumb. Like, why did I think that I would need a separate function for that? Doesn't really make any sense at all. You would just do like... You would just say that you needed that many bytes, like the number of bytes that you need for an entity, right? So my thinking that I needed two different things for that is just dumb, because why? Like there's no need for that, right? It's just used byte count or whatever, right? And then it's like U8 bytes. It's the same thing we were doing before. You just say size of entity times 16 or whatever, however many you wanted of, right? Like however many you wanted to store. And then when they're packed, you just don't use that size. You use whatever the size of the packed thing is that you wanted, but it just seems kind of obvious, and I have no idea why I didn't think of that. Just really stupid. Really, really stupid. I don't have an explanation for that other than just being dumb. So anyway, so then we would just say, in here, when we say use block space, we just say, oh, do we have room for the actual thing? We need to have this be differentiated because there's two different ones of these. So this does have to be done in the outside, but this internal part here, we can have be the same. So we just need to be able to differentiate between these two different versions, the first packed or first unpacked. So I think, because if I look at it here, we really just need that pointer, and then this thing can be done entirely on its own, right? So all we would say here, in fact, the chunk is not necessary. So really all we're going to do is say, hey, we need that first pointer. So entity block pointer, and we're just going to say like entity block so if there's nothing there, or if it doesn't have room, then we make a new one of these things, and we set it equal here, right? And we pull it off here. And that's it, right? Okay, so use block space is now actually generic. I thought it wasn't going to be, but it actually turned out to be. And so now we don't really have to do what I thought we had to do before. That was totally false and not correct at all. And really all I had to do was just use the same exact thing in both cases, but in one case I just asked for the size of an entity, whereas in the other case I asked for some arbitrary size depending on how we want to pack our entities over time, which is fine. Okay, so that is, as they say, that. I think. What is the problem here? Does not have a member of Unpacked. I agree with you. Okay. So that's fantastic, because that means that now all of this gets replaced as well. Right? So all of that goes away, and we just say packed entity size. U8 star dest equals use block space world chunk first packed entity size, right? I guess this should probably return a U8, because why is it returning a void for no reason? Nobody knows. Least of all me. Okay. Happy birthday, that's all written out. The entity loop here is actually over like an entity count, which is just the unpacked used byte count divided by the size of an entity. Hardly anything exciting. And then we're done. So that was like a gigantic waste of time that I did there first, but at least we realized the correct thing to do, so we didn't leave the code dumb for no reason. And so now it's better. I think that's it. So that's the whole thing. What I would like to do is really quickly before we forget, when we do create entity here, this code now, we now know what this code actually is, right? We grab a world chunk. I don't know what the difference is between these two things. So we want the full one. We want the big daddy, right? So we would say there's the arena that the world uses, which is this thing here. And we would say, okay, we want to get the world chunk that this entity would be in. We want to ensure that it's unpacked because we're actively like adding crap to it, right? So we want to say like, yeah, unpack it, and then we would just say use block space. In that chunk. And that's it. Now, though it's the first, it's first unpacked like that, right? I think. Use block space, chunk, first unpacked, size of entity. Yeah. It doesn't like that, though, for some reason. Well, I thought that was beautiful. I don't know why the compiler has a problem with it. It's just a lame compiler, really. Apparently. Come on. I should have moved that function up to the top. Oh, it's just I didn't capitalize entity. Sorry. All right. So I think that's everything. And in theory, I'm sure we got some bugs in there, but I think that's basically it. And so all we have to do next time is just work on the iteration side. Because that's all this other stuff is down here. I'm going to move create entity up because this other stuff is just iteration. And so I'm going to go ahead and go up above the iteration stuff here. And I'm just going to put there we go. The rest of the stuff in here. But yeah, that's it. Very small amount of code, should work fine. All right. I think I'm going to call it there today. Next time, we will work on that iteration part of things. And then we're kind of in the home stretch for a fairly gigantic change. But that I think will be it's going to be a much smoother running program. And simpler with this much stuff removed from it. So that's kind of nice, which is always the goal of exploratory architecture, is to don't just keep adding things. When you find that you don't need stuff, make a concerted effort to improve, right? Delete the things you don't need and retighten, just so you can get things running smoothly, right? Otherwise you end up with these gigantic sprawls that are very hard to manage, if that makes sense. So, all right. Seems good. That's about it. Yeah. That's it for today. I will be back to do the other part next time. And yeah, we still, because it's not quite December 25th, all of our stuff at Molly Rocket is on sale. If you use the code, I will post the video link for anyone who wants it in the chat. But basically, if you just go to youtube.com/mollyrocket, the first video on there, or second video, is the holiday sale video. So I'll just paste it in for you. If you're interested in the holiday sale, it's there. That's about it. So until next time, I will see everyone on the internet, I guess. Take it easy, everybody.